Hey Jordan, this talk is about question answering, so let's answer some questions. What percentage of people-based questions in natural questions are about women?
Well, 50.8% of the US population is female.
Nope, lower than that.
Well, they're a little bit over 40% of the workforce. How about that?
Nope, still lower.
Oh, heavens. A quarter?
Yes, more or less. Only 27% of questions about people in natural questions are about women.
But natural questions is an outlier, right? Surely other data sets are better.
On the contrary, natural questions has the highest fractions of questions about women among other popular question answering datasets. Could you try to guess what's the case for Squad?
Oof, well, even lower? 15% maybe?
No, it's way lower than that. Squad's development poll just has around 5% of questions about women.
But that doesn't make a lot of sense given how well question answering systems have been doing, conquering leaderboards and trivia whizzes. Is that in spite of the lack of diversity in the training set?
Well, that's what we're going to find out. This paper analyzes the representation across demographic groups in question answering datasets. Existing work in AI fairness focuses on disparate impacts on people and that model behaviors are prone to harm, especially when it comes to people.
You started off talking about natural questions and Squad, which most people know about. Are you going to talk about any other datasets?
We also consider open domain datasets like QuizBowl and Trivia QA. Each of these four datasets has its peculiarities. For example, natural questions is sourced from Google search queries. QuizBowl reflects an undergraduate curriculum and captures more academic knowledge. Trivia QA is a popular trivia, while Squad reflects some selected Wikipedia articles and a batch of questions over it. We focus on questions that are about people.
But how do you know when a question is about a person?
For that, we use an entity linker. It parses text and highlights mention of named entities. And we can filter out questions that don't have a mention of person in it.
But that just tells you that you have an entity, not anything about it.
Well, that's where the linking of the entity linker comes in. It also maps entity to their entry in the Wikipedia.
So this is where you get the depressing gender statistics we started with. What about other entity properties?
For all datasets, men from the US and the UK form an extreme majority. Natural questions has the relatively highest coverage of women, though the focus is primarily on the entertainment-based professions. On the other hand, QuizBowl is rich in writers and politicians. For Trivia QA, professions are fairly distributed.
Okay, so you've convinced me that question answering datasets lack representation, but who cares? As long as it gets the right answer, what's the problem?
Well, for that we need to see if the QA system performs well for all the subgroups. We take a state-of-the-art system for each of our four datasets, but instead of looking at the aggregate dataset level accuracy, we look at the accuracies for demographic subsets. And we see a lot of variance. For instance, while just 66.2% of questions about people are correct in QuizBowl, the number is even much lower for the Dutch and much higher for Ireland. Unsurprisingly, accuracy is consistently low on the not found subset where Wikipedia lacks a person's demographic value.
But how do you know that that's real and not just noise?
To see if the trends are statistically significant, we use the chi-square test. Chi-square test is a non-parametric test of whether two categorical variables are independent. Here, we want to see if accuracy and characteristics are independent, hence we apply chi-square test to an n×2 contingency table. N rows represent the frequency of each characteristic subsets, for example, male for gender, while columns represent correctness for model prediction, that is correct or incorrect. Let me highlight the datasets and demographic characteristics that are statistically significant with the Bonferroni correction. Nationality doesn't play a significant role in accuracy. Gender does, but only for natural questions, while professions are significantly impacting accuracy for all datasets except Squad. Accuracy for women is higher than that of men. That must be very reassuring.
But Maharshi, we have three different values for gender in natural questions: male, female, and male-female, which also happens to have a very low accuracy. How do we know that it's not that particular subset of entities that's causing the chi-squared test to us a statistically significant result?
So let's dig deeper using a logistic regression. Can an example's demographic values predict if a model answers it correctly? We defined binary features for demographic values of the characteristics the chi-square test found significant. For instance, an example focusing on William Shakespeare would have positive values corresponding to the features gender male and occupation writer.
But logistic regression is such a weak model. It's not named after a Muppet and doesn't have a hidden layer. Why use it?
We are not doing model calibration here. We are only trying to explain what's going on. And logistic regression is better at getting weights that humans can interpret.
There are tons of other things that make a question hard other than the demographic properties of the entities.
Exactly. So we add those alternate explanations as other features. Questions are harder the more entities they talk about. So if n is the number of people found in the questions, we add the logarithm count of entities as a feature called multi-entities. Questions are also easier if they look like evidence. So we have Jacquard similarity between question answer.
So after correcting for these alternate explanations of what makes a question easy, do demographic characteristic properties affect accuracy at all?
Features with positive weight mean that they are associated with easier questions, like the question evidence similarity and answer type words. For natural questions, the evidence similarity feature has a weight of 0.406. On the other hand, features with negative weight are associated with harder questions. For example, presence of multiple entities in natural questions and quiz bowl. To answer your primary questions about demographics, we have three major takeaways. First, professions have strong effect on model accuracy and does fairly well with the entertainment field. However, unlike trivia QA, both natural questions and quiz bowl perform poorly around science and technology. Secondly, there is no significant gender strata in natural questions. It was indeed the low accuracy of the combined male-female category that you guessed, which was revealing the high significance in the chi-square test. The questions, in general, performs poorly when there is more than one focused person in the question. And thirdly, we don't see any significant influence of nationality on model accuracies.
So the case is closed then. No need for any more AI fairness papers about question answering.
No, this was just the beginning. We see that this was a classic case of absence of evidence, and we should not take this as evidence of absence. The datasets indeed are heavily skewed. For instance, Quizbowl hardly has 10% of examples asking for women, while Squad even less than that. In natural questions, the majority of questions about women are from one of the entertainment sections, which it anyway performs well on. The lack of representation in question answering could cause us to think that things are better than they are because of Simpson's paradox. Gender and profession are not independent.
Okay, so you've convinced me that QA datasets are skewed, but you haven't convinced me that there's a problem in terms of accuracy. And I suppose that the only way that I'm actually going to be convinced is if you build a actually representative question answering dataset where we see some effect on accuracy.